Have you ever wanted to run a PowerShell script on a remote system, or maybe even a collection of remote systems which requires a different credential set than the one you're currently logged in with? Normally, you'd create a credential object in your session, but at some point would be prompted for the username and password. Otherwise, you could hard code the password directly in your script, but that wouldn't be safe since anyone who can read your script can also see that password. Assuming you don't already have a cloud or third-party solution to manage your credentials on premises, what if you wanted several administrators on your team to be able to use multiple service account credentials from multiple machines in your enterprise while keeping the passwords for those service accounts confidential? Well, now you can do that natively with the latest version of Windows PowerShell, which at the time of this recording is version 5.1. Hello, and thanks for checking out this video. My name is Preston K. Broussard, and full disclosure, I'm a Microsoft Premier Field Engineer specializing in platforms, automation, and Azure infrastructure technologies. I must also point out that any views and opinions presented in this tutorial are my own and not necessarily those of my employer. So why would we use certificates to secure credentials? Well, we can use certificates to authenticate PowerShell commands and scripts, minimize prompting for service account credentials, and even safely store service account passwords in an encrypted format to provide confidentiality. This tutorial will explain and then demonstrate the process of securing credentials with certificates for PowerShell commands and scripts using PowerShell. This will be presented in 4 main parts, consisting of first logical views of the processes, then the physical views, followed by a set of other scenarios that can be used for this solution. Finally, I'll show a demo of the entire set of processes that are involved. Step 1. Enter the artifacts directory where the certificate, service account username, and password files will be stored, along with the service account that will be encrypted and exported to the artifacts directory. Step 2. Since this is the initial execution of the script and we haven't already created a self-signed certificate, we'll need to create it by selecting the Export Cert switch. Step 2b. Next, a new self-signed certificate for document encryption will be created, followed by a prompt requesting the service account password. The service account password is then encrypted and exported to the artifacts directory specified earlier in step 1. The username file is also exported to the artifacts directory, but this is in clear text. Finally, the self-signed certificate, including its private key, is also exported to the artifacts directory. Now that we've installed and exported the self-signed certificate, we can run the script again, but this time we won't specify the export cert parameter to indicate that we intend to retrieve and use the credential that was previously exported. First, we'll import the certificate, then retrieve the clear text username and encrypted password, decrypt the password using the private key of the imported certificate, construct a credential object based on the retrieved username and now decrypted password, and finally display the secured credentials to show that it was successfully retrieved and reconstituted so that it can be used in the same PowerShell session. Now we'll change the perspective to the physical view of the infrastructure. More specifically, we're looking at the single account, single host scenario where a single user usr.g1.s1 is logging on to a single development machine AZR dev 1001 to execute the script. The infrastructure consists of the following components: a domain controller, a development server from which the scripts will be executed, a file server that will host credential and certificate artifacts as well as the transcript. The user account usr.g1.s1 is used to represent a privileged account that will execute the script. Step 1. When we run the script initially, we'll enter the artifacts directory where the certificate, service account, username, and password files will be stored, along with the log directory and service account that will be encrypted and exported to the artifacts directory. Since this is the initial execution of the script and we haven't already created a self-signed certificate, we'll need to create it by selecting the Export Cert switch. Next, a new self-signed certificate for document encryption will be created, followed by a prompt requesting the service account password. The service account password is then encrypted and exported to the artifact directory specified earlier in step 1. The username file is also exported to the artifacts directory, but this is in clear text. Finally, the self-signed certificate, including the private key, is also exported to the artifacts directory. We're still looking at the infrastructure view, but now that we've installed and exported the self-signed certificate, we can run the script again, but this time we won't specify the export cert parameter to indicate that we intend to retrieve and use the credentials that was previously exported. First, we import the certificate, then retrieve the clear text username and encrypted password. Decrypt the password using the private key of the imported certificate. Construct a credential object based on the retrieved username and decrypted password. And finally, display the secure credentials to show that it was successfully retrieved and reconstituted so that it can be used in the same PowerShell session. Some of the other scenarios that are supported include single account, multiple host. This is the situation where a single user, like usr.g1.s1 shown here, logs on to multiple hosts azr dev 1001 and azr dev 1002 to execute the script. In contrast, we could have multiple users like usr.g1.s1 and usr.g2.s2 both log on to a single host. This is the multiple accounts, single host scenario. Finally, we can expand the scope of this solution to both multiple accounts and multiple hosts, where all designated administrators can log on to any machine and in the domain that supports PowerShell 5.0 or later and execute the script. Shown here are both the usr.g1.s1 and usr.g2.s2 accounts having the potential to log on to either or both of the azr dev 1001 and azr dev 1002 hosts to run the set self-signed cert creds.ps1 script. In this demo, we'll download the script from the script download link in the public GitHub repository. Open the script in an administrative context of the user account usr.g1.s1 and execute both the create certificate and use certificate options. And lastly, we'll test the retrieval, decryption, and use of certificate account credentials. The first step is to log on to your development server or client machine. In my case, I've already logged on to my development server, which is a Windows Server 2016 Data Center Edition. In your own environment, any client or server machine that has PowerShell version 5.0 or later will work. Next, I'll open VS Code as administrator. Once the initial profile loads, I can use Control-Shift-P to open the command palette and enter PowerShell restart current session. This will open the PowerShell integrated console. You can use any other PowerShell IDE you prefer, like the native integrated scripting environment or Visual Studio 2017 with the PowerShell Tools extension. We'll need the PowerShell script for this solution, which is hosted in a GitHub public repository. So let's create a new directory to download the GitHub project files. I'll create a new folder in my user profile with the name of the project number, which is 0051. Now I'm ready to download the project files archive from my public GitHub repository. I'll use the Explorer executable within the PowerShell console to download the zip file. When prompted to open or save the file, I'll select Save and save it to my 0051 folder that I created earlier. Now I can open the archived file and navigate to the 0051 directory and copy the extracted files to the same directory. This will create a subfolder named 0051-set-self-signed cert creds.ps1-master. In this folder, I need to unblock the PowerShell script if my execution policy is set as remote signed. Now I can open the script in my script editor for execution. Now I can open the script in my script editor for execution and change the script directory in my terminal window. Since this is the first time I'm running the script, I'll use the export cert parameter so the certificate can be created. Now when we launch the script, we'll get a summary of the service account name, artifact and transcript directory, and whether the export switch was specified. I'll type yes to continue since I'm satisfied with the values of all these parameters. Now we'll get an outline of the operations that the script will use, namely to create the certificate, prompt for the service account password, encrypt and export it along with the username and certificate to the artifact's location. I'll press enter to continue. The script will show the properties of the document encryption certificate that was created and also prompt me for the service account password. The encrypted password will be displayed to indicate that the encryption was successful, and I will also be prompted for the certificate private key password so that the certificate can be exported. The thumbprint is shown, as well as the exported certificate path and the script complete, prompting me if I'd like to open the transcript file. I'll type yes to see the transcript file quickly and review its contents. The transcript reflects the output that was displayed in the console anyway. This is great because I have a log of everything the script did in this session so far, and I can use it for troubleshooting, further script development, or even reporting. So far, we've created the required certificate and service account credentials that will be used to authenticate commands and scripts in our session. But because these have been exported to a different server, we need to first retrieve the credential, decrypt the password, and reconstitute it so we can use it later. We'll run the script again, but this time we won't include the export switch since the certificate has already been exported. As you can see from the output, the credential, username, and password for the service account was retrieved and is now ready to use. To test authentication of a PowerShell command on a remote system, we'll list the directory of the C drive on the domain controller AZR ADS1003 using the credentials of the service account. The directory list is shown, which verifies that the remote authentication was successful. So there you have it. Once you set up the self-signed certificates by initially running this script with the export cert switch, retrieve and install the certificate and the credentials, you get the convenience of no longer having to manually enter passwords for the service account credentials. The service account password is encrypted with the document encryption certificate so that you created with the self-signed certcred.ps1 script and exported to a restricted share on a separate server. So this password is confidential. The only other people that can decrypt it are those administrators that already know the private key password and have access to the restricted network share where the certificate was previously exported to. Finally, this solution is scalable because multiple administrators can log on from multiple machines in the organization and actually create multiple encrypted service account credential sets for subsequent use in PowerShell commands or scripts. Magic. I want to send a big thanks to all of you for watching this, and if you really enjoyed this video and want to see more of these tutorials, make sure to like this video and subscribe to my channel. I'd love to hear from you too, so please, any feedback on what you liked and what I can do to make these videos even better for everyone, send them so you and your staff can become heroes and heroines. Thanks again for watching, and happy automating.